So today we're going to talk about equations as function rules. We have something called function notation. And in function notation, we need to remember that y is the same thing as f of x. So anytime we're looking for the y value, f of x really means the same thing, whereas x is still the x value. So here we're given this function, and we're asked what is the value of f of negative 2. So what I'm going to do is I'm going to take this function and I'm going to clean it up in this square. So I'm going to write f of x equals, now in my mind I'm going to write 3x plus, and then I'm going to multiply. 4 times x is 4x, and 4 times 1 is 4. So I'm going to write plus 4x plus 4. And then I'm going to simplify even further, so that's going to be f of x equals 7x plus 4. Now, I'm looking for f of negative 2. So I'm going to write that directly below, f of negative 2. The negative 2 is referring to the x value. Notice they line up when I write them here. So what I'm going to do is I'm going to input negative 2 wherever I see x into this function. So I say equals 7, instead of x, I'm plugging in negative 2 plus 4. So now I go about the normal way of solving. I say f of negative 2 equals 7 times negative 2 is negative 14 plus 4, which happens to be negative 10. So I have f of negative 2 equals negative 10. So that's the solution. That's what they're looking for. Another way of writing this is the x value is negative 2 and the y value is negative 10. So technically speaking, that includes the point negative 2, 10. The function notation is a little bit weird, but we just got to get used to it. In this case, they're looking for f of x equals 39. I'm going to write my simplified equation. Again, it's the same thing as up here, only I had already simplified it. So f of x equals 7x plus 4. Now they're telling me f of x is equal to 39. So wherever I see f of x, I'm going to replace it with 39. So here is f of x. I'm going to replace it with 39. So 39 equals 7x plus 4. Then I'm going to solve. The normal way I solve, subtract 4 from both sides. So 35 equals 7x. Divide both sides by 7. So x equals 5. X value is 5. The y value, or the f of x value, is 39. So technically I have the point 5, 39. Either way is the correct answer. It's just two different ways of writing it. Down here, another example. F of x equals negative 2x minus 4 times x minus 1. Again, first thing I'm going to do is I'm going to take this and clean it up. So I'm going to write f of x equals negative 2x. Then I'm going to distribute. This negative 4 goes here and here. So that gives me a negative 4x, and a negative 4 times a negative 1 is a positive 4. Cleaning it up further, I get f of x equals negative 6x plus 4. Now they're asking me to find f of 3, so I'm going to line it up. F of 3. The f of 3 tells me they want me to plug in an x value of 3. So I'm going to say negative 6 times 3 plus 4. Negative 6 times 3 is negative 18, and negative 18 plus 4 is negative 14. So f of 3 is negative 14. Again, it's that way, or it can be written as the point 3, negative 14. Over here, I'm going to go back to my simplified version of my equation, which is right here. F of x equals negative 6x plus 4. This time they're saying f of x equals negative 17. So wherever I see f of x, I'm going to replace it with negative 17. So negative 17 equals negative 6x plus 4. Then I go about solving. Minus 4, minus 4. So negative 6x equals negative 21. Divide both sides by a negative 6. So it's not perfect, but 21 over 6 reduces to, divide by 3, 7 over 2. Negative divided by negative is a positive. So this is a solution, or I could write 7/2, comma, negative 17. Looking at a different thing, same thing, but on the back. Here they're asking me for the points. This is the x value, this is the y. So they're looking for y, but giving me the x. I'm going to use my equation, and I'm going to simplify. So I'm going to write y equals, here I'm going to put 9x minus 6. Now I'm going to plug in for x, 10. So y equals 9 times 10 minus 6, which is 90, minus 6, 84. So my y value is 84, and since we've already been seeing it in a point, 84 goes for the y value. Here, they're asking for the x value and giving the y value. So here, y is 12. So I'm going to, again, use my simplified equation. Y equals 9x minus 6. Plug in 12 for y. So 12 equals 9x minus 6. And then solve. Add 6 to both sides. So 18 equals 9x. Divide by 9. So x is 2. Again, that's part of the point. So it's 2 comma 12. This function is done exactly the same way. I'm going to input 1 for x, and out will come the y. I'm going to then input 27 for y, and out will come the x. On the last one, they're giving me the domain and asking me to find the range. If they give me the domain, I plug in for x, these values one at a time. However, if they give me the range, I plug in the y values in for y and solve one at a time. It's very important that you pay attention to what they're asking for. Before I do anything, I'm going to clear this up a little bit. So 1/2 x plus 2x is 2.5x. So I'm going to say y equals, instead of 2.5, I'm going to say 2.5x minus 1/2, which is 0.5. Now I'm going to plug in the first value first, negative 1. It's for x. So y equals 2.5 times negative 1 minus 0.5. So that is negative 2.5 minus 0.5, which gives me negative 3. So that's the first y value. I need to hold on to it because the range must be from least to greatest, and this may not be the least. So here, y equals 2.5. Instead of x this time, I'm going to put a 0. So times 0 minus 0.5. Anything times 0 is 0, minus 0.5 is a negative 0.5. So that's the second value. And finally, the third value, I'm going to say y equals 2.5 times x. The x value in this case is 1 minus 0.5. 2.5 times 1 is 2.5. Minus 0.5 is 2. So here's my three y values. The least one happens to be negative 3, but it's not always going to be that way. Then negative 0.5, and then 2. Domain and range from function notation.